Hi guys, so this is the question number 8 of NMTC Stage 2 Inter Final. Okay, so let's see this question. In this we have given ABC is a acute angle triangle. A circle passes through A and the circumcenter O. So we just draw a circle which passes through A and a circumcenter of O. So again it is there are infinite many circles we can draw passing through A and O. So let's say we draw any random circle passing through A and O which intersect AB and AC at P and Q. Okay, and we have to prove that orthocenter of POQ lies on the line BC. So the orthocenter, okay, orthocenter of triangle POQ lies on the line BC. So for that, what I did, I draw perpendicular from O on PQ and extend it to a line BC. Okay, so let's say this point is H, and as we know that the length of perpendicular, or sorry, the length of AH, like in case of a triangle, if we draw the orthocenter, the distance of a vertex from the orthocenter is 2r cos of A. We can use mod of that, because cos A can be negative also. So 2r cos of A. Now in our question, as we draw AH, we at the place of A we have a O, so we draw OH, right? And we want to prove that H is the orthocenter of this triangle. So if we somehow prove that OH is twice of R, where R is the circumradius of POQ triangle, okay, into cos of angle POQ. Yes or no? Can we say that? So if we prove that length OH is 2 times R, capital R cos of POQ, then we are done. I think that is clear. So here R is circumradius of triangle POQ. Or let's say it is R dash. Okay. So we assume capital R is the radius of triangle ABC. So R is the circumradius of a triangle ABC. Okay. Now we want this 2R dash cos POQ. So what is cos POQ? What is this angle POQ? So POQ angle, like I think all of you know this angle. This angle is 90 minus B, because O is a circumcenter, and OA makes an angle 90 minus B with the AC line, and this angle is 90 minus C, right? Now if we do the angle chasing, like they APOQ are concyclic, APOQ are concyclic, so this angle is 90 minus B, and this is 90 minus C. Then by angle sum property, this angle becomes 180 minus angle POQ is 180 minus 90 minus B plus 90 minus C, which is B plus C, and in fact it is 180 minus E, right? So POQ angle is 180 minus A, so we can say that OH we want to prove 2R dash cos 180 minus A, which is cos A. Yes, sir. We want to prove that OH is 2R dash cos A. That is the one thing. Now okay, so OH is 2R dash cos A. Now let's see, means that we want to prove that 2 OH becomes 2R cos A. Now let's see how we can do that. This is the perpendicular, right? And I want to find out this length, or I want to prove this length is 2r cos A. So let's see how to, okay, to find out OH, I will use this triangle OBH. We can use a triangle OBH to find out OH. And what is OB? OB is capital R. It is the radius of a circumradius of a triangle ABC. So, and this angle we know it is 90 minus A. OB makes an angle BC with the 90 minus A, and this angle can we find out? As we know, this angle AOB is 2C. AOB angle is 2C, and we need this angle also, so that we can use a linear pair to find out this angle. So and I also know this angle is 90 minus B. This is 90, so I know this complete angle is B. I know this complete angle is B. So if we assume that this angle is theta, okay, let's say this is, we assume this angle is theta, then this part of angle is B minus theta. So then what should be this angle? 180 minus 2C minus B minus theta. So it is 180 minus 2C minus B plus theta. So we can simplify it like B plus C, we can write 180 minus A. If we put in this angle 180 minus C as it, minus C minus B is 180 minus A plus theta. So what we will get, 180 will cancel out, A plus theta minus C. So this angle is A plus theta minus C, and this angle again 180 minus these two angles. So A plus theta minus C plus 90 minus A, that is 90 plus theta minus C. So this is sum of these two angles. So if we subtract from 180, it is 90 plus C minus theta, right? So let's write OH now. So OH by sine rule, I can say OH by sine 90 minus A is equal to R by sine 90 plus C minus theta, right? So it becomes OH is sine 90 minus A is cos A, R cos A by cos C minus theta. What we want to prove it? 2R dash cos A. We want to prove this is OH is 2R dash cos A, and we are getting OH is R cos A by cos C minus theta. And in fact that R dash is the circumradius of POQ, and this R is the circumradius of AOB. Can we relate these two radii, R and R dash? Okay, let's see that. If we see the triangle, if we consider OA, O is a capital R, and if we see this angle, this angle, this part of angle is 90 minus B, right? And this angle is theta. By angle chasing, we can say this angle is theta, because this angle is equal to, like, angle POA is equal to angle PQA. So we can say that that AO chord makes an angle 90 minus B plus theta on the circumference of this circle, right? On this circle. So and AO is the chord of this circle which makes this angle. Then we know by the formula that AO is equal to 2R dash cos, so it's sine of this angle. sine of this angle, that becomes 2r dash cos theta minus b, and AO is basically capital R. So we can put R is capital R is 2r dash cos theta minus b. Okay, theta minus b. I think I just made a mistake here. It is 90 minus c, not a b, right? 90 minus c. This angle is 90 minus c because from here it is 90 minus c, so this is 90 minus c. So it is theta minus c. So if I put in this formula, we will get OH is 2r dash cos c. That we want to prove, right? So that's why H is the orthocenter of the triangle POQ.